Let us first understand what is inverse of a function. Consider any function f defined from x to y such that the set x contains 1, 2, 3, 4 and the set y contains a, b, c, d and e as their elements. Domain of f is 1, 2, 3, 4 and codomain of f is a, b, c, d, e. Similarly, range of f is a, c, d. Clearly, the function is not 1, 1 as for the elements 1 and 2 in domain, there is only one image a in the codomain. Click on every highlighted point to know more. Let us study graphical representation of 1, 1 functions. Consider a function y is equal to fx as shown in the graph. Now, consider lines drawn parallel to the x-axis for different values of y, such that the line intersects the graph at x1, y1, x2, y2, x3, y3 and x4, y4. We observe that for different values of y, we have unique value of x. So, the function y is equal to fx is 1, 1. It is also called as an injective function. Now, consider another function y is equal to gx as shown in the graph. Consider lines drawn parallel to x-axis for different values of y, such that the lines intersect the graph at x1, y1, x2, y2, x3, y3, x4, y4, x prime 4, y4, x prime 3, y3, x prime 2, y2 and x prime 1, y1. Here, we observe that for a single value of y, we have two values of x. Thus, this function gx is not 1, 1. This is also called as a many-one function. Consider any function f defined from x to y. Now, we also see that the given function is not onto function because range of f is not equal to codomain of f. That is, range contains the elements a, c, d, whereas codomain contains the elements a, b, c, d, e, which are totally different from each other. Let us study graphical representation of onto functions. Consider a function y is equal to sin x defined from r to minus 1, 1 as shown in the graph. Now consider lines drawn parallel to x-axis for values minus 1 to 1 of y. Here the codomain is minus 1 to 1 and we observe from the graph that y is equal to sin x covers all the values in y belonging to minus 1 to 1. Thus, range of y is equal to sin x is minus 1 to 1. So, codomain equals the range. This function is onto or surjective function. Now, let's define y is equal to sin x from r to r. We can observe from the graph that range is minus 1 to 1, but in this case the codomain is r. Therefore, codomain is not equal to the range. Therefore, function is not onto. This function is neither 1, 1 nor onto. Therefore, its inverse cannot be defined because inverse of a function is only defined when the function is 1, 1 and onto. A function f defined from set x to set y is defined to be invertible if there exists a function g defined from set y to set x such that gof is equal to ix and fog is equal to iy, where ix and iy are sole functions of x and y. The function g is called the inverse of f and is denoted by f inverse. Now, let's transform the function into a 1, 1 and onto function so that we can find its inverse. Since no two elements have same images, hence this function is a 1, 1 function. Now, let's change it into an onto function. Since range equals codomain, we know that a function f defined from set x to set y is invertible if and only if f is 1, 1 and onto. Thus, this function is invertible. Let us define a function g which is the inverse function of f. G is a function defined from set y to set x such that domain of g equals range of f and range of g equals domain of f, where G can also be denoted as F inverse.